So in the last video, we learned how we can implement a basic Pipecat pipeline for your voice agent. But as we know, it's not limited to that. We would want to obviously customize the behavior of our agent, right? So before we dive deeper into how actually chats and context is handled in LLM, let's just get an example out of the way where I will just explain how do you do actually in the code, right? So basically, you have this LLM context, and every message, the conversation chat history is stored inside the context. So what you need to do is while instantiating the context, you just need to also pass in the message. For example, here we are creating a restaurant booking example. So we give it a role of system, and then we provide the content which has to be there, right? So this contact is this is more than enough for any AI agent to be customized. And now, when the pipeline runs, AI has read this message, and then AI will predict next message based on this message, right? So you have essentially customized your AI agent. But Pipecat, or in fact any other voice agent, would be a lot more complicated than this. That's why we first need to understand the internals of our application, right? Like how does Pipecat handles everything in the first place? So let's get a deeper dive. First of all, yeah. So first of all, let's understand how LLMs work in the first place, right? So I draw simple illustration to explain this. So first things first, we need to know is LLMs are stateless. What I mean by that is that from an application perspective, you pass in a list of messages to an LLM, and then all LLM does is predicts the next one. That's it. Other than that, it's the client's responsibility to handle all the context, which means in our case, Pipecat is the one who is handling all the context for us, and we are at the liberty to modify Pipecat's behavior to tweak the LLM context, right? So first things first, LLMs are stateless. So application initially send entire chat context every time, and then AI just predicts the next message. And therefore, it's client's responsibility to manage the chat context. The second thing is that tool calls, right? Tools calls are basically nothing but a message entry where client receives the message where AI is saying that you need to place this tool call, and then client executes that tool call and returns the message back. While you are working with Pipecat, you would obviously create a function, but this is what is going on under the hood. Which means if you look at your chat context, you will actually see tool call invocations and responses back, right? And then lastly, it is not compulsory to run LLMs, which means it does not mean that if you are appending a message, you need to run an LLM. While we create complex applications, there are a lot of cases where we would just need to insert a message, and then LLM would then be not called, right? LLM would be called at later stages. So this is where it is very important to know that it is up to us to run LLMs, right? So because in this series we would be creating a very non-trivial and complicated application, which you might not find in the examples repository of which Pipecat provides, right? The example which we are working on is the restaurant booking example, but we would go a step ahead. We would also add functionalities on the front end, which then tweak the AI agent to work in a certain way. In order to make it work, we first need to understand how LLMs are basically processed, right? So to summarize, LLMs are stateless. You handle the chat history, you handle the tool call invocations, and it is not at all compulsory to run LLMs. You can always keep on updating chat history and only run LLM when you want to predict next message, right? So now this is the general framework, which means any framework which you deal with is providing some or other way to connect with LLMs. Now let's see how Pipecat handles those LLMs in the first place. Okay, so Pipecat has an object called LLM context. What this object does is that it holds the context of the LLM, and then it is attached to a pipeline or a task, which means every frame has the access to LLM context, right? So the way this works is that there is this thing called context aggregator, which is a pair, right? So you essentially create an aggregator which provides you two frame processors, which sit at different stages in your pipeline. They read through frames and then they manage the context in that way. Which means if you want to talk to aggregator, the best way is to pass frames, right? So what happens is that LLM context holds the message and tools, and then the other message utils are also part of the context, right? You don't directly work with the context, you are essentially triggering context aggregator, right? So you have LLM context aggregator, which is sitting at different layers, and then all the LLM star frames which you pass through are used to tweak LLM somehow, right? So other frame processors send LLM star frames to work with context, and then every frame has a flag called run LLM to decide if you actually want to reach out to AI, right? Which means it is corresponding to the place where it is not compulsory to run LLM, right? So you would want to, in a lot of cases, you would want to tweak the chat context, but you would not want to run LLM right away. In that cases, this is the one. So, while we are at it, we can also look at some important frames which you can deal with when you are working with the context, right? So we have first here LLM run frame. So let's say in an example, in a very non-trivial example where you have a lot of frames working together and you are not running the LLM right now, and you want to run an LLM, you just pass in this frame. As soon as this frame is triggered, the context aggregator will run the LLM on the chat context which it has, right? So then we have message append frame, which means if you want to append the message to an existing chat history, right? So this is where you can send this frame down, and then as soon as this frame is read, it will append the messages inside that frame. And then second is the update. If you want to wipe out the chat history and start from fresh, you use this frame, which means the array of messages which you pass here are essentially replacing your old chat context, which means after the next LLM invocation, these frames, these message would be treated as scratch from the AI's perspective, right? Then we have this transform frame where we can you can attach a function to transform the messages. As I said, it is not ideal to directly modify the context object. That's why this, right, because Pipecat is a very modular framework. You might have set different frames sitting at different layers, also figuring out some meanings out of it, right? In those cases, when you directly modify the context LLM context, you might create a lot of bugs and you might miss out a lot of optimization opportunities which is created by other frame processors. And lastly, there is set tools frame where you can set tools for your application. There are a lot more LLM frames, but these are the ones which would pretty much cover a good enough non-trivial use case, right? Now that we know which frames are there, it is also very important to know the best practices for passing in the frames, right? So, this is a illustration which tells you what is the best practice to actually pass and consume frames, right? So, you will be dealing with frames in two ways. Either you are passing them or you are consuming them. So as you know that there are two ways to pass a frame. If you are at a processor level, right, which in most of the cases you would be at a frame processor level, which means that your code is being executed at certain frame, right? So in those cases you can push down the frame. But what is the problem with that is that the frames processors which are above are won't be notified about that, right? Unless you explicitly push the frame up, there is no way for other frame processors to know that the frame has been passed, right? And this might create bugs. This might hurt your modularity because let's say tomorrow if you change the order of the frames, you are messing up your frame structure and you are essentially coupling your frames together, which you don't want to do. So then the best way is to pass the frames from the task object, right? So basically a task contains a list of frames. I have talked in detail about this in my previous video. So when you pass frame from a task, what happens is that it passes the frame all the way from top to the bottom, unless any one frame processor consumes that and doesn't pass that back. Which comes to our next point is that while you are consuming frames, the only way, in fact, for you to consume frame is by being a frame processor, which means you inject your code as a frame processor at some level, and then whenever the frame is received from above, the frame processor is notified about that frame, and then you can create your behaviors there. Also, there is something called observers where you can deal with frames, but that we won't get into that right now because that is a yet complicated deep dive which we will be doing later, right? So so these are the two ways for you to push the frame, and then this is the one way to consume the frames, right? When you are creating a frame processor, it is an absolute necessity that you always push down the frame which you don't want, which means that you use this Python's utility called instance of, where every frame is a class. So you use the instance of method to check whether that frame belongs to the frame which you want to process. If you want to process, it's fine. But if you do not want to process, it is your responsibility to push it down. If you don't push it down, then the bottom frames don't get notified about it, and you are at a chance of breaking the functionality. So unless you are absolutely sure about what's happening, it is good to pass the frames. Yeah, so this has been a deep dive on how actually LLMs are handled. The example which we dealt with is only creating message at the first level, which means when we instantiate an object, we are also sending a message, setting message in context. But as we go deeper, as we dive into deeper examples, we would be dealing with these frames. Specifically, when you want to handle front-end interactions. On the web page, let's say you want to create some special buttons and then you want to tweak your agent, then these concepts will help you a lot. Right. So I think that's it for this video. We understood how LLMs are actually meant to be used. And then in later videos, we will create more non-trivial examples where we will be using custom frame processors and we will be dealing with a lot of custom frames as well. Right. So